Today, we're diving headfirst into one of the most thought-provoking theories in astrophysics. Get ready to challenge your beliefs and open your mind as we explore the intriguing notion that the Big Bang didn't happen. The Big Bang hypothesis, which states the universe has been expanding since it began 14 billion years ago in a hot and dense state, is contradicted by the new James Webb Space Telescope images, writes Eric Lerner. To everyone who sees them, the new James Webb Space Telescope (JWST) images of the cosmos are beautifully awe-inspiring. But to most professional astronomers and cosmologists, they are also extremely surprising, not at all what was predicted by theory. In the flood of technical astronomical papers published online since July 12, the authors report again and again that the images show surprisingly many galaxies that are surprisingly smooth, surprisingly small and surprisingly old. Lots of surprises, and not necessarily pleasant ones. One paper's title begins with the candid exclamation, "Panic." Why do the JWST's images inspire panic among cosmologists? And what theories' predictions are they contradicting? The papers don't actually say. The truth that these papers don't report is that the hypothesis that the JWST's images are blatantly and repeatedly contradicting is the Big Bang hypothesis that the universe began 14 billion years ago in an incredibly hot, dense state and has been expanding ever since. Since that hypothesis has been defended for decades as unquestionable truth by the vast majority of cosmological theorists, the new data is causing these theorists to panic. "Right now I find myself lying awake at 3 in the morning, says Alison Kirkpatrick, an astronomer at the University of Kansas in Lawrence, and wondering if everything I've done is wrong. It is not too complicated to explain why these too small, too smooth, too old and too numerous galaxies are completely incompatible with the Big Bang hypothesis. Let's begin with too small. If the universe is expanding, a strange optical illusion must exist. Galaxies or any other objects in expanding space do not continue to look smaller and smaller with increasing distance. Beyond a certain point, they start looking larger and larger. This is because their light is supposed to have left them when they were closer to us. This is in sharp contrast to ordinary, non-expanding space, where objects look smaller in proportion to their distance. Smaller and smaller is exactly what the JWST images show. Even galaxies with greater luminosity and mass than our own Milky Way galaxy appear in these images to be 2 to 3 times smaller than in similar images observed with the Hubble Space Telescope (HST), and the new galaxies have redshifts which are also 2 to 3 times greater. This is not at all what is expected with an expanding universe, but it is just exactly what I and my colleague Riccardo Scarpa predicted based on a non-expanding universe, with redshift proportional to distance. Starting in 2014, we had already published results, based on HST images, that showed that galaxies with redshifts all the way up to 5 matched the expectations of non-expanding, ordinary space. So we were confident the JWST would show the same thing, which it already has, for galaxies having redshifts as high as 12. Put another way, the galaxies that the JWST shows are just the same size as the galaxies near to us, if it is assumed that the universe is not expanding and redshift is proportional to distance. But from the standpoint of the Big Bang, expanding universe hypothesis, these distant galaxies must be intrinsically extremely tiny to compensate for the hypothesized optical illusion implausibly tiny. One galaxy noted in the papers, called GHZ2, is far more luminous than the Milky Way, yet is calculated to be only 300 light-years in radius, 150 times smaller than the radius of our Milky Way. Its surface brightness would be 600 times that of the brightest galaxy in the local universe. Its density and that of several other galaxies in the new images would be tens of thousands of times that of present-day galaxies. Tiny and smooth galaxies mean no expansion and thus no Big Bang. Big Bang theorists have known for years from the HST images that their assumptions necessitate the existence of these tiny, ultra-dense, Mighty Mouse galaxies. JWST has made the problem far worse. The same theorists have speculated that the tiny galaxies grow up into present-day galaxies by colliding with each other, merging to become more spread out. An analogy to this hypothetical merger process would be to imagine a magical toy car a centimeter long that nonetheless weighs as much as a SUV and grows up into a real SUV by colliding with many other toy cars. But the JWST has shot through this far-out scenario as well. If you could believe the toy car story, you would at least expect some fender dents in the colliding cars. And Big Bang theorists did expect to see badly mangled galaxies scrambled by many collisions or mergers. What the JWST actually showed was overwhelmingly smooth disks and neat spiral forms, just as we see in today's galaxies. The data in the Panic article showed that smooth spiral galaxies were about 10 times as numerous as what theory had predicted, and that this would challenge our ideas about mergers being a very common process. In plain language, this data utterly destroys the merger theory. With few or no mergers, there is no way tiny galaxies could grow to be 100 times bigger. Therefore, they were not tiny to begin with, and thus the optical illusion predicted from the expanding universe hypothesis does not exist. But no illusion means no expansion. The illusion is an unavoidable prediction from expansion. Thus, the panic among Big Bang supporters. Tiny and smooth galaxies mean no expansion and thus no Big Bang. Since nothing could have originated before the Big Bang, the existence of these galaxies demonstrates that the Big Bang did not occur. Too old and too many galaxies mean the same thing. The JWST uses many different filters to take its images in the infrared part of the spectrum. Thus, it can see the colors of the distant galaxies. This in turn allows astronomers to estimate the age of the stars in these galaxies, because young, hot stars are blue in color and older, cooler stars, like our Sun, are yellow or red in color. According to Big Bang theory, the most distant galaxies in the JWST images are seen as they were only 400 to 500 million years after the origin of the universe. Yet already some of the galaxies have shown stellar populations that are over 1 billion years old. Since nothing could have originated before the Big Bang, the existence of these galaxies demonstrates that the Big Bang did not occur. Just as there must be no galaxies older than the Big Bang, if the Big Bang hypothesis were valid, so theorists expected that as the JWST looked out further in space and back in time, there would be fewer and fewer galaxies and eventually none, a dark age in the cosmos. But a paper to be published in Nature demonstrates that galaxies as massive as the Milky Way are common even a few 100 million years after the hypothesized bang. The authors state that the new images show that there are at least 100,000 times as many galaxies as theorists predicted at redshifts more than 10. There is no way that so many large galaxies can be generated in so little time, so again no Big Bang. Based on the published literature, right now the Big Bang makes 16 wrong predictions. And only one right one: the abundance of deuterium, an isotope of hydrogen. The Big Bang prediction of the abundance of helium is off by a factor of 2, the prediction for the abundance of lithium is off by a factor of 20. In addition to the absence of the larger, more distant optical illusion, there is also the existence of large-scale structures too big to have formed in the times since the Big Bang, wrong predictions for the density of matter in the universe, and well-known asymmetries in the cosmic microwave background that should not exist according to theory. There are many more contradictions. In early July I published 2 comprehensive papers summarizing the situation. Based on the published literature, right now the Big Bang makes 16 wrong predictions and only one right one: the abundance of deuterium, an isotope of hydrogen. If you found this episode fascinating, don't forget to hit that like button, subscribe, and ring the notification bell so you never miss an episode.